Boeing just revealed something about the 777X that nobody expected. 30 aircraft already built, sitting in facilities right now, but airlines cannot take delivery. Not because of delays, but because of something else entirely. Here is what Boeing admitted that changes everything about the 777X program. Boeing reports that approximately 30 Boeing 777X airframes that have already been built will require modifications before they can be delivered to airline customers. The company produced these airframes prior to the aircraft type being fully certified. This decision, perhaps overly optimistic about the early design, was made while hoping to get deliveries started as soon as possible. The result is that significant work will need to be done to these aircraft to make them compliant with final certification specifications. The information was conveyed during Boeing's first quarter earnings call in late April 2026. CEO Kelly Ortberg revealed his company had created a dedicated team to handle the modification work on these already built aircraft. Flight Global reported that some 30 early 777Xs need modification and upgrade before delivery. Sources indicated each jet now requires updates to incorporate modifications that emerge during flight testing, FAA certification activities, and manufacturing process refinements. Air Data News covered that Boeing says 30 built 777X jets will require modifications before delivery. The publication emphasized the scope of work facing Boeing engineers. Ortberg was quoted stating, "We've got roughly 30 777s that'll go through this change incorporation process over several years." He added, "For the airplanes that we have built, we need to incorporate all of the changes that have happened since they've been built." This statement reveals the magnitude of the challenge. The modifications will not happen quickly. Boeing expects the process to extend over several years. The amount of work required will depend on airframe age. Older aircraft naturally require more extensive modifications. Some may need structural changes. Aircraft built earliest in the production run diverge most significantly from final certification standards. As Boeing refined the design through testing, changes accumulated. Early airframes lack these refinements. The situation somewhat reminds industry observers of what happened with the Boeing 787 Dreamliner. The early production group of Boeing 787 aircraft became known as the Terrible Teens. Boeing had not fully completed the Boeing 787 development process when these aircraft were built. The Terrible Teen jets were part of testing and early production runs prior to full certification. These Dreamliners had faults, including structural weaknesses where the plane's wings joined the fuselage. To meet federal standards for sale, Boeing installed custom-fitted reinforcements. These modifications made the jets heavier than later production aircraft. The Terrible Teen Dreamliners proved difficult to sell. Airlines preferred later production aircraft without the weight penalties and modifications. Some Terrible Teen aircraft remain in service today, but they represent cautionary examples. The 777X situation parallels the Boeing 787 experience uncomfortably. Boeing is again facing the consequences of building aircraft before finalizing design through certification. Whether the 777X modifications will make these first 30 airframes heavier remains uncertain, but they almost certainly will not be lighter than post-certification builds. At best, modifications will keep weight close to standard production aircraft. The actual weight difference between the earliest in service 777X models and later production aircraft will not be known until modifications complete. But any weight increase negatively impacts aircraft performance and economics. Heavier aircraft burn more fuel. Range decreases. Payload capacity reduces. Airlines pay for these penalties throughout the aircraft's service life. This makes early 777X airframes potentially less desirable than later production units. Boeing's decision to assemble airframes before certification pointed to high optimism that minimal changes would be required. The company calculated that getting ahead of certification would enable faster deliveries once approval came. It is a calculated risk. Even with expected modifications during certification, if changes are minimal, Boeing and airline customers benefit from getting airframes faster than waiting for full certification before starting serial production. Another benefit is building workforce experience in the assembly process while certification is ongoing. Workers learn procedures, identify issues, and improve efficiency before high-rate production begins. These are understandable benefits. Boeing's logic makes sense from a business perspective. Start production early, refine processes, and be ready to deliver immediately when certification completes. But But the strategy carries significant risk. If certification reveals major issues requiring substantial modifications, early built aircraft become problematic. This appears to be exactly what happened with the 777X. The modifications needed are extensive enough that Boeing created a dedicated team to handle the work. This suggests more than minor tweaks. Substantial engineering and manufacturing effort will be required. The multi-year timeline Ortberg mentioned indicates complex work. Simple modifications complete in weeks or months. Multi-year timelines suggest structural changes, systems updates, and extensive testing and verification. For airlines with early 777X delivery positions, this creates uncertainty. Will their aircraft be among the 30 requiring modifications? If so, how will modifications affect delivery schedules? Airlines ordered 777X aircraft expecting specific performance characteristics. If modifications change weight, range, or other specifications, airlines may need to reevaluate how these aircraft fit their operations. Emirates, the largest 777X customer with over 200 aircraft on order, will likely receive many of the early airframes. Whether Emirates accepts aircraft requiring modifications or demands later production units remains to be seen. The modifications also add cost. Boeing must pay for engineering work, manufacturing changes, and the labor to physically modify 30 aircraft. These costs were not originally budgeted. Additionally, aircraft sitting awaiting modification occupy factory space and tie up capital. Boeing invested billions building these 30 airframes. That money cannot be recovered until aircraft delivered to customers. Every month these aircraft sit undelivered costs Boeing financially. The company needs revenue from 777X deliveries desperately. The delayed revenue from these 30 aircraft affects Boeing's cash flow and financial recovery. The 777X program has already consumed over $15 billion in development costs. Boeing has not delivered a single aircraft to customers yet. Each additional delay and complication increases the financial burden. Investors are watching the 777X program closely. The aircraft is critical to Boeing's widebody strategy. If the program fails or significantly underperforms, Boeing's competitive position against Airbus suffers dramatically. The modification requirement for 30 early aircraft is not catastrophic, but it is another problem in a program plagued by problems. The 777X has faced years of delays, certification challenges, and technical issues. Each setback erodes confidence incrementally. Airlines, investors, and regulators all question Boeing's ability to execute major aircraft programs successfully. The 777X was supposed to redefine long-haul wide-body aviation. Revolutionary folding wingtips, record-breaking GE9X engines, massive capacity, and exceptional efficiency. Boeing positioned it as the Boeing 747 and A380 successor. But constant delays and problems have tarnished the 777X's reputation before it even enters service. Airlines wonder if the aircraft will deliver promised performance. Investors question if Boeing can profitably produce it. Now, Boeing admits 30 early airframes need substantial modifications before delivery. This does not inspire confidence in the program's execution. The decision to build aircraft before certification appeared bold and confident. Boeing was signaling trust in its design and engineering. The company expected minimal changes during certification. Instead, certification revealed enough issues that 30 aircraft now require multi-year modification programs. This represents a significant miscalculation. Boeing could have waited for certification to complete before starting production. This would have avoided the current modification requirement. Aircraft built after certification would meet final standards from the start. But waiting would have delayed first deliveries further. Boeing chose to accept modification risks to enable potentially faster time to market.